Alright, so welcome back to the second part of the video. In the second part of this video, we are going to discuss what is the theoretical maximum power extractable from the wind. And when we say extractable, it also means that we want to determine what is the wind power that is contributed by the wind turbine. So what we discussed in the first video will form the basis of this second part of the video. So if you have not understand this first part of the video yet, I strongly encourage you to go through the first part of the video again. Okay, so let's begin by saying that only a fraction of the total theoretical power available in the wind is extractable due to various energy losses. And this is what we are expecting as an engineer, because there's no perfect system and there's always energy loss due to heat, sound, friction, and so on and so forth. So if we can envisage a particular wind turbine as such, okay, where it is receiving a particular amount of incoming wind blowing at a particular velocity, and then exiting the wind turbine at a particular velocity v2, and then the wind turbine is rotating at a particular speed called vr. So when a particular wind velocity attack the wind turbine, and because it goes through the wind turbine, the wind velocity will reduce when it passes through the wind turbine and end up as a smaller V2. Therefore, the kinetic energy would reduce as well according to such. Okay, where we can say that the kinetic energy before entering the wind turbine is larger than the kinetic energy exiting the wind turbine. So we can take the difference between them, and then we can determine what is the kinetic energy that has been lost. And again, now we want to determine what is the power that we can extract from wind turbine. So if we know from the first slide from the first video is that to determine wind power, we simply take the differentiations of the kinetic energy. Oh yeah, one remark I forget to say: when you take the difference between these two, then you obtain the difference in kinetic energy, and this difference in kinetic energy represents the kinetic energy that has been absorbed by the wind turbine. All right. So this is a differentiation of dke dt. So this kinetic energy is the kinetic energy that we saw earlier, and then we can substitute. We go ahead and substitute this thing inside the ke term over here, and then we expand it. And as we expand, then we obtain this form. Okay. So when you obtain this form, then we also know that at the same time, the mass of the air is rho ax, which we know from the first video. And then if we perform dmdt, because dmdt is what we want, then you obtain this form, and dx dt again is the velocity of the air. Okay, distance change over time is velocity, and but this time it's not the air velocity, because we are now deriving the energy that is lost or absorbed by the wind turbine. Therefore, dx dt represents vr, which is the velocity that the wind turbine is rotating at. So we substitute this dmdt into this, and then into here, and then we rearrange the equations, and then we end up with this form. Okay, rho avr v1 square minus v2 square divided by 2. Right. Now the ms passing through the rotor, all right, undergoes not only an energy reductions but also a reduction in linear momentum. So what we have calculated just now over here is a reduction in velocity. By using the concept of reduction of velocity, we determine what is the extractable power from the wind turbine. But there's also one more thing that we didn't consider, which is the reductions of the linear momentum. So reductions of linear momentum is a simple mass multiplied with velocity. So the velocity attacking the turbine and the velocity exiting the turbine will give us the reductions of the linear momentum as such. All right. So we can also go ahead and take a differentiation of this, because we want to find the maximum loss of the linear momentum. If we find the maximum loss of the linear momentum, then we have found the maximum momentum absorbed by the wind turbine. All right. So we take the differentiation against time as well, And then we take the